Okay. So good day everyone. So today we're going to answer the problem, what you call this one? Problem exercise 3.3, which is under the chapter 3, which is motion in two or three dimensions. This is section 3.1, which is under the topic of position and velocity vector. So again, I'm Professor Fis, or I'm Prudence Fis B. Bustamante. I'm working in the Surigao del Norte State University, Philippines, and we're going to answer this problem here. So so here in this problem, okay, uh, we have a web page designer creates an animation in which a dot on a computer screen has a position vector r as a function of t, okay, given by this equation. Okay, given by this equation here, you can see that in your screen, which is a function of t, okay, and find the magnitude and the direction of the dot's average velocity between the interval t is equal to 0 and t is equal to 2.0 seconds. And for letter B, find the magnitude and the direction of the instantaneous velocity at t is equal to 0 and t is equal to 1.0 seconds and t is equal to 2.0 seconds. For letter C, sketch the trajectory from t is equal to 0 and t is equal to 2.0 seconds and show the velocities calculated in part B. Okay. So here, let's answer first letter A. Okay, letter A. Okay, so for letter A, find the average velocity between this interval. Okay, given this position as a function of time. So here, uh, at t is equal to 0, okay, as a function of t, so we call this one as r sub o, so is equal to uh, 4.0 centimeter plus 2.5 centimeter per second squared, okay, times 0 squared multiplied by I hat plus 5.0 centimeter per second, okay, times 0 j hat. So here, when t is equal to 0, our position, r sub o, is just equal to 4.0 centimeter I hat, or 4.0 times 10 to the negative 2 meters I hat. So when our position, when t is equal to 2.0 seconds, so this is, we call this one as R2, okay? When t is equal to 2.0 seconds, so we have actually here 4.0 centimeter plus 2.5 centimeter per second squared, multiplied by 2.0 seconds. Then we're gonna square this one, okay? I hat plus 5.0 centimeters per second, multiply this one by 2.0 seconds, okay, j hat, okay. So here, in the first term, we have 4 centimeter, so this is 4 centimeter, and we have here, actually, so we have here 4, okay, 4 s squared, so we can cancel this out, and you can cancel this out, so we have 4 times 25, it's actually 4 times 2.5, so it's actually 10. Okay. So here we have 4 plus 10, we have 14 centimeter I hat. Okay, I hat. Plus here we have, we can cancel this out, we can cancel this out, 2 times 5, so we have 10 centimeter kj hat. So it means that this is our x1, this is our, for example, you can note that one as our initial position, x2, this is our y2, or the final position along y, and we know that y1 here is equal to 0. y1 means initial, y2 means final. Okay. So from the definition of the average velocity, we have here uh, v average along x is just equal to the displacement along x2 minus x1 over the time interval. So we know that the time interval is 2.0 seconds. So, change of t is equal to t2 minus, um, or t1, which is equal to 2.0 seconds when 0 is equal to 2.0 seconds. So here, our x1, our x2 is 14 centimeter. Our x1 is minus 4.0 centimeter. We divided by 2.0 seconds. So we'll have 10.0 centimeter, divide by 2.0 seconds. So we have 5.0 centimeter per seconds. For our v average along x, average velocity na to along y, I mean, so we have y2 minus y1 over time interval. Okay, time interval. So it will give us, so our y2 is 10 centimeter, our y1 is 0. Okay, so we have 2.0 seconds. So it will give us, so so 10, it will give us 5.0 centimeter per second. So the same. So now we now have the x and y component. So we can now determine the magnitude and direction of the average velocity between that interval. So once we have the, so first we need to determine the magnitude. Okay, so let's find, so we have a graph first. Okay, this is our x and y graph. Okay, this is so here we can see that our v average along y is positive, and our here, so v average along x is also positive. So meaning our vector lies on the first quadrant. So uh this is actually our v average, or our vector v lies on this. So in what direction? So we can determine that later. Okay. So for the magnitude, so we have, for the magnitude of that vector, it's just equal, just actually v average along x squared plus v average along y squared. So this is actually the square root of 5.0 meters, centimeters per second squared plus 5.0 centimeters per second, again squared. Okay, so it will give us, for the magnitude, so we're gonna use our calculator. Okay, bear with me. So we have the square root of 5 squared plus 5 squared. So we have 7.1. So our magnitude is 7.07 meters per second. So this is our V average, the magnitude of our average vectors. That is our magnitude. So to find the angle theta here, angle theta or the direction, so you can use this tangent. So I'm gonna put this one, tangent of the theta is equal to the opposite, which is the y. So over v average along x. Okay. So implies that our theta is equal to the tangent inverse of the v average along y over v average along x. So this is up. So our theta here is the tangent of shift, tangent of 5, 5, or tangent of 1. So we have 45 degrees. So theta is 45 degrees. Okay. So here, our direction, you can say that our theta, or the direction is equal, direction is 45 degrees. So this is uh, north of east, okay? Or you have 45 degrees from the between the or from or between the positive x from the positive x axis. Okay. Okay, you can do that or you can just 45 degrees. So much for that. So let's answer letter B on the next video. So please click and subscribe. Please click the subscribe button and leave a comment for questions.